Okay, this is video 1 for chapter 12 of Levin's book, chi-square tests and non-parametric tests. Probably this will be all text video. I doubt we'll reach any point where we'll be graphing anything, and if we do, we'll start the next one. Okay, these are the rubrics covered in chapter 12. Chi-square tests for the difference between two proportions, independent samples. This title reminds us there are different types of chi-square tests, and we'll go on the internet to remind ourselves about other types. But they'll be looking at the difference between two proportions test. This is the main one we'll be looking at. Next, chi-square tests for differences among more than two proportions. Obviously will be the extension of this test. And chi-square test of independence. Then new test, McNemar. And by the way, this is the Morris-Kuilov procedure you were wondering about, because you forgot it from the lecture when it was mentioned during the lecture. Next one is McNemar test for the difference between two proportions. And we already had difference between two proportions tested by chi-square test. But in this case, there's going to be the samples are going to be related. So anyway, there's McNemar test for the difference between two proportions. Let's change the color so we can see the difference. Next is Wilkinson rank sum test. That's important too. Rank sum test. Non-parametric analysis for two independent populations. We're going to check once again the difference between parametric and non-parametric analyses, the presence of assumptions or not, coming from the particular probability distributions or not. So we'll see a lot of Wikipedia pages in this video. Next one is Kruskal-Wallis rank test. Rank test, non-parametric analysis for the one-way ANOVA. We'll go back to one-way ANOVA with this test. Let's see what we can pick here. Let's try this greenish. And these are definitely the companions we'll be looking at for graphing videos. Okay. Chapter objectives. Learning objectives. In this chapter you learn how and when to use the chi-square test for contingency tables. So hopefully you will learn how and when. I'm afraid we'll have to read a lot of other sources to really answer this question. How to use the Morris-Kuilov procedure for determining pairwise differences when evaluating more than two proportions. That's the key. More than two proportions. Keep going back at that arrangement. How and when to use the McNemar test, and how and when to use non-parametric tests. Okay, we know that the Excel examples will be very good, but most of the other presentation will have to be really worked on hard. Here's the scenario they're giving us. We'll have to come back to it several times during the reading of the text. You are the manager of TC Resort Properties, a collection of 5 upscale hotels located on 2 resort islands. Guests who are satisfied with the quality of services during their stay are more likely, so satisfied, are more likely to return on a future vacation and to recommend the hotel to friends and relatives. To assess the quality of services being provided by your hotels, guests are encouraged to complete the satisfaction survey when they check out. That's not smart. The impressions of service are usually the best when they're compared to other services. So the best way to really find out if people like your hotel is to wait several weeks or maybe months so they can go back to their recollections and see from the time perspective how good or how bad it was. You need to, and that's based on those recollections, they'll be making next year's decisions, not immediately when they leave the hotel. You need to analyze the data from these surveys to determine the overall satisfaction. I'm grabbing it very well. Overall satisfaction with the services provided. So there's overall satisfaction, the likelihood of return to the hotel, and the reasons some guests indicate they will not return. So you need to analyze the data from these surveys. Let's try to use the rectangle, maybe it'll work better. To determine the overall satisfaction with the services. Determine the likelihood of return. Likelihood of return to the hotel. And the reasons for not returning on the part of some guests. And the reasons for not returning. So we have 3 tasks here. 3 tasks facing the questionnaire analyst. And designer too, by the way. So for example, on one island, TC Resort Properties operates the Beachcomber and Windsurfer hotels. That's 2 hotels. Is the perceived quality at the Beachcomber hotel the same as the Windsurfer hotel? Perceived quality, they do not define it here. It may be some sort of combination of scores, we'll see later. Is the perceived quality of these hotels the same? If a difference is present, let's see if difference can be highlighted normally. If a difference is present, how can you use this information to improve the overall quality of service at TC Resort Properties? Okay, if a difference is present. Okay, assess the quality of services. Then, to assess the quality of services, here's a survey in which data will be analyzed to answer these questions. Overall satisfaction, likelihood of return, and reasons for not returning. Okay. Furthermore, if guests indicate that they are not planning to return, what are the most common reasons? See, somehow you need to separate the common reasons given for this decision. Are the reasons given unique to a certain hotel? That's a good question. Are the reasons given unique to a certain hotel or common to all hotels operated by this chain? They always want to know that. In the words of our president, to know whose ass to kick. Okay. Unique to certain hotel or common to all hotels operated by RC Resorts. Resort Properties. Okay. In the preceding chapters, plural, in the preceding chapters, you used hypothesis testing procedures to analyze both numerical and categorical data. Very good point. Here we'll be using a lot of categorical data. Chapter 9 presented a variety of one-sample tests, and Chapter 10 developed several two-sample tests. Chapter 11 discussed the analysis of variance ANOVA that you use to study one or two factors of interest. This chapter extends hypothesis testing to analyze differences between population proportions based on two or more samples, as well as the hypothesis of independence in the joint responses to two categorical variables. Now, what the heck is this once again? This chapter extends hypothesis testing, so there will be hypotheses, the null hypothesis and the alternative hypothesis. This chapter extends hypothesis testing to analyze differences, important keyword. We'll be looking at differences again, just like with t-test, to analyze differences between population proportions based on two or more samples. Here's one, right? One task for this chapter. Okay, so analyze differences between population proportions based on two or more samples. And we have to think about the scenario again. We're going to have two hotels we'll be dealing with, and the guests in the two hotels will be filling out the identical survey. Okay. As well as the hypothesis of independence in the joint responses. So we need to copy this. Okay. Got the independence right here. So we'll test the differences between population proportions based on two or more samples, as well as the hypothesis of independence in the joint responses to two categorical variables. Joint responses. We'll have to look at this. It's an important keyword to remember, joint. We have joint responses. They will be looking at the whole mix of questionnaires. Two categorical variables. The chapter concludes with non-parametric tests as alternatives to several hypothesis tests considered in chapters 10 and 11. Okay, chi-square test for the differences between two proportions. Once again, chi-square tests are used for answering different questions. In this particular case here, we'll be dealing with two proportions and looking if the differences between them are significant or not. Let's highlight this. Differences between two proportions. In section 10.3, you studied the z-test for the difference between two proportions. In this section, the data are examined from a different perspective. The hypothesis testing procedure uses a test statistic. Here comes a new test statistic that is approximated by chi-square distribution. We have a new distribution to look at. Chi-square distribution. Why the heck it exists and how it really influences the decisions, we might look at a little later, not right now. The results of this chi-square test are equivalent to those of the z-test described in section 10.3. Okay, we're going to stop here and let this